Hello everyone and welcome back to this tutorial this week where we're going to be focusing on points, lines and polygons. I hope you watched the previous video. This one now is going to be on lines. Okay, I'm going to go fairly quickly on this. So we have an ability to create line strings. Okay, so this is basically a collection of at least two different points which then we can draw a line between. Okay, so in Shapely this is defined as a line string, and this object represents one or more connected linear spleens between the points. So a spleen is kind of the line that might connect those two points. Okay, repeated points in the ordered sequence are allowed, but may incur performance penalties and should be avoided. A line string may cross itself and therefore be complex and not simple. Okay, so let's have a go. The line string function is what we're going to import. And here we're going to go to the Shapely geometry library. We're going to import the line string function. Here we're going to put in two individual coordinates, so 2, 3, and 3, 4, and they're in a list, you'll notice. And then we pass that list of tuples to the line string function, and it creates this line here that's been printed. Okay, so that should be, although it's an abstract space, you should be able to see a line and kind of think that it's something more tangible than the point that we covered previously. Let's just confirm exactly what that is, and we know that it's a Shapely geometry object because it's allowed us to use the geom_type function, and it's given us this line string. Okay. We have similar functionality to how we approached those points previously. So right now we're able to print the area of our line, and because this isn't going to be connecting anyway with any of the sort of coordinates, it means the area of the line is going to be 0. Okay. But in this case, we will have a much clearer length than before. Okay, so a line is going to have a length that's going to be between, in this case, the two coordinates that we've actually got within our line string. And the units here, as I mentioned before, are going to be dependent upon the coordinate reference system which you put in. Shapely is fully agnostic about this, so it's down to you to make sure that you get the right coordinates for all of your different units. They need to be in the same coordinate reference system. You can't take a measurement between something which is in a projected unit and something which is in an unprojected unit, because it will just produce a nonsense result. Okay. We're also able to take the bounds for our line, so it's able to print here, so for the minimum x value and the maximum x value, and the minimum y value and the maximum y value. Finally, we can access the coordinates within our Shapely object easily. So here we're going to go to our object, we're going to ask for the coords part of that object. It's going to give us a coordinate sequence object, and then we can use the list function to convert that coordinate sequence into a set of coordinates. And here it's a list containing two tuples, with each of those tuples being the coordinates that we placed in earlier. So you've been able to go from actually having coordinates which you place into this function, and then essentially a set of coordinates that you're able to extract after you've created that Shapely object. Okay, so that should give you an understanding of how we're able to create these Shapely objects, do something with them like measure the distance or the area depending on what sort of object you've got, and then extract those coordinates at the end. So let's have a go now at this exercise to just kind of recap on that information that you've just learned. I'd like you to make sure that you definitely have a go trying these before you get to looking at the answers with me. Okay. So look, we've got this set of points. We've got x1, we've got x1, y1, x2, y2, x3, y3. Okay, so this is for our simple line. So let's create one of those. I'm just going to reuse the code that we've got before. So we're going to call this simple line. What we're going to do is we're going to go 2, 2, 4, 4, 2.5, 3.5. Okay, this is for our simple line. And now for our complex line, we're basically going to have an extra one of these on the end. Great, so that's loaded. So simple line. There we go, there's a simple line. And then we have, oh, I was expecting that to do something different, so bear with me 1 second. 2, 2, so that's wrong, it should be 4, 4, 2, 2, 2.5, 3.5, there we go. 2.5, 3.5, 4, 2. Perfect. Here's our complex line. So you can see the difference because when we focus on the simple line, it's just 2 lines, they're not touching at all. Then when we actually go to the complex line, you can see that they're crossing. It's going to end up being a more complex shape. And you're able to do this within Shapely, which is very nice. So you then should be able to find the area. So let's go print. There we go, so we've got the length for the simple line and the complex line. And there we go, we've got the area. Remember, you should have 0 area for your line. We're then able to find the bounds. So these are the bounds of the 2 different lines that we've got, so 2 and 4 for the simple line. And actually, they both have the same bounds, okay? It's just that they have different structures overall. Now let's compare the lengths of these 2 lines. Well, we've already done that, so we don't need to do that final one. Perfect. Great, well I hope that that was of use to you. Hopefully you've been able to have a go at that exercise and understand how these lines were created. Don't hesitate to reach out to me or the Learning Assistants if you've got any further queries. And I'll see you in the next video for the focus on polygon objects. Thank you, goodbye.